Hello, my name is Mark Kozdras. I'm a materials scientist and research manager at the Canmet Materials Laboratory in Natural Resources Canada. As part of my technical duties as a federal researcher, I became the co-lead of the Clean Energy Materials Innovation Challenge, IC6, within Mission Innovation in 2018. When the wall fell on November 9th, 1989, I was in my university laboratory preparing to defend my PhD thesis in mechanical engineering at the University of Waterloo. I learned very early in life that I wanted to be an engineer as a result of my love of math and science. In university, I learned that materials science was my passion. I had a strange intuition about the way materials behaved, and it intrigues me to this day. After becoming a professional engineer in Ontario, it became clear to me that I would serve society through technical innovation. I was lucky enough to work in both an industrial and government research setting throughout my career. My research breaks the wall of affordable clean energy for all. The challenge my project addresses is to accelerate the availability of affordable clean energy solutions. Up to 80% of the cost of clean energy solutions comes from the materials used, and it can take up to 20 years of research and development to commercialize new materials. It may be helpful to refer to the PowerPoint slide that was provided. As the co-lead of Clean Energy Materials Innovation Challenge, IC6 of Mission Innovation, we created a vision and a roadmap to realize accelerated materials discovery. The workshop report can be found at the IC6 website of Mission Innovation. Through MAPS, or Materials Acceleration Platforms, we harnessed three advanced technologies: robotic automation, high-performance computing, and artificial intelligence to accelerate the development of inexpensive, environmentally friendly materials. MAPS have also been referred to as self-driving laboratories. Our goal is to accelerate materials discovery by a factor of more than 10. The approach is to couple modern technologies in an integrated system. Natural Resources Canada is developing maps for materials that convert waste heat energy to electricity, known as thermoelectrics, and also invested in Project Ada at the University of British Columbia, led by Dr. Jason Hein, to enhance the conversion of light to electricity with novel materials for organic solar cells. At the inaugural IC6 workshop in Mexico City in September 2017, Nobel laureate Mario Molina described MAPS as the second revolution in science. The MAPS approach will require skilled personnel in diverse disciplines like mechatronics, computation, machine learning, and neural networks, as well as conventional chemistry and material science. This innovative approach to develop new materials will expedite the development process for low-cost energy solutions and bring new devices to the market as we race against the climate change clock. The vision of the Clean Energy Materials Innovation Challenge is to see MAP assets in every corner of the globe and will involve academic, government, and industry-based research facilities. Canada took a leadership role in this effort, but many countries are supporting the challenge. This technology will lower the cost and time required to achieve the 2-degree Paris Agreement goal. The essential new finding of the research is that through a paradigm shift in the way we conduct materials research and development, we can realize higher performance energy materials on a highly accelerated schedule. Self-driving laboratories can work around the clock and search for new materials more efficiently and effectively than ever imagined, thanks to the convergence of artificial intelligence, high-performance computing, and robotics. MAPS will complement and enrich the researchers of tomorrow. It is impossible to replace human intuition, but MAPS provide access to insights we might not realize otherwise. Society will benefit from the wider availability of affordable, clean energy technologies that wean us from carbon-intensive technologies and build a green economy. A key question that remains is whether society will see MAP technology as a path to decarbonization, and whether industry will see it as a key enabler to economic success. That's what we're focusing on now. Which part of your research keeps you lying awake at night? My greatest concern is that with only 3 years to develop MAPs under the Clean Energy Materials Innovation Challenge, we won't achieve a critical mass and be sustainable internationally. Technically, accelerated materials discovery is now possible. It is very important that the underlying need for clean energy innovation continue to receive support from initiatives like Mission Innovation. My daughter Stephanie is a third-year chemical engineering student at McMaster University. She's tracked MAP's development from its inception and is working in project data at the University of British Columbia today. Stephanie sees the importance of the multidisciplinary approach and feels that she can contribute in a meaningful way with her growing understanding of chemical processes. She's part of the solution. She believes that MAPS will radically change the way experimental science is done, and she is inspired by the possibilities that accelerated materials discovery brings to this and future generations.